Hey y'all, welcome to Heart Academy for November 5th, 2018. And this is Earth Science homework assignment for tonight, Monday evening. And so I'm just going to walk you through the reading and answer the questions with you so that it's a little bit less time consuming for you to do the assignment based on today's lesson, which was an introduction to the Earth's layers. So I meant to do this before I got home, but I was having computer problems, printing problems, everything problems, but that's okay. So again, I handed this out in class, this for homework, and if you weren't in class, you can download it and print it yourself from the Google Classroom, or you can use the Kami app and write on the document using your phone and submit it through Google Classroom. That way, it's due tomorrow. Also, remember, grade checks were completed today, and updates will be given out again tomorrow to make sure everyone's on track with what they need. If you have any missing assignments, etc., please come see me tomorrow. And starting tomorrow, you can also stay with me during lunch for the week to complete any missing labs or missing assignments or anything like that. That'll help you right on through. And typically, I will not be doing that because I value my lunchtime. But since it's taking me so long to get all the grades and stuff in, I'll help you through getting the first 2 weeks stuff done, especially if you're confused with what to do and how to process everything quickly. All right, so this was the homework for tonight, reading with some questions that are on the sidelines right here. And so we're going to go ahead and go through this. And I'm just going to answer accordingly, or you can just read everything yourself and answer how you feel. So we're talking about the Earth structure right here. And let's see. Okay, so Earth structure. Well, we have the key concepts. You always want to make sure that you read about the key concepts that are here. What are we going to be talking about in this chapter? What are the interior layers of the Earth? And what evidence indicates that Earth has a solid inner core and an outer liquid core? So things that we're going to be looking for as key concepts in this read. So these sections or worksheets have a first part that's called Before You Read. And it asks you questions before you start reading about the information that's provided for you. So what do you think? Luna, what do we think? My dog's looking at me like, what in the hell? She's so cute. Okay, so before you read, what do you think? Read the two statements below and decide whether you agree or disagree with them. Place an A in the before column if you agree with a statement, or a D if you disagree. After you read this lesson, reread the statements to see if you have changed your mind. So we're going to read the before sections, right? Why are you doing that? Look how cute this dog is, right? How could you not be that? I'm going to stop getting distracted here. Like to sniff the ears. Okay. So, statements before. What do we think? Earth's interior is made of distinctive layers. Do we agree or disagree? If you agree, put an A here. If we disagree, put an A here. Or put a D here. And number 4, scientists discovered that Earth's outer core is liquid by drilling deep holes. Okay, so if you agree, put an A here. Or if you disagree, put a D here. Now, just for curious sakes, I know these answers, but I'm just going to say I disagree with everything. So I'm going to put a D here. You can put your choice, A for agree or D for disagree. So I'm going to put, oh look, it gives you a little thing where you can write in it. Okay, well, there we go. I'll put a D. All right, so now we will read. Read to learn, clues to Earth's interior. You cannot identify, mark the text. Okay, as you read, highlight any word or term you don't understand, or use a dictionary to look up the meaning of these key words and terms, and keep a list of their definitions. Hey, that's exactly the reason why I gave you a little composition book for definitions and new vocabulary words. So you know what you can do with that. So read to learn, clues to Earth's interior. All right, you cannot see very far inside Earth. The deepest mines and wells do not go much deeper than Earth's surface. How did scientists learn about Earth's interior? They used many methods to discover what is under the surface. Now, if you were in class today, you missed an awesome little activity lab that I did, and we mimicked how scientists drill inside the Earth by using very large drills. However, in class, we use cupcakes and straws. Close enough. So here, what's below Earth's surface? Scientists use deep mines and wells to get clues about what is below Earth's surface. The deepest mines ever made is more than 3 what km? Kilometers? What's km stand for? Km. Is that kilometers? Kilometers? Km. Who? Okay. So the deepest, that was my husband, by the way. Huh. So the deepest mine ever made is more than 3 kilometers deep. People can use this mine to explore the geosphere. The deepest well is more than 12 kilometers deep. People cannot go down into this well. Instead, they bring samples to the surface. They also send tools down to make observations. Hey, we have a predict question over here. Predict what kind of things might scientists measure in a mine or a well? Well, I would predict that they would measure what kind of things might scientists measure in a mine or well. Oh, look, maybe the liquid or wetness. Perhaps they would measure. What other things would they be able to measure? What kind of things might scientists measure in a mine or a well? Oh, let's see. What else would I measure? Maybe. What kind of things would scientists measure in a mine or a well? Just in earth science. So what? A mine or a well. What kind of things would scientists want to measure? Huh? Volume of what? Okay. Sounds good to me. That was our dog. The well water. Oh, okay. Maybe even the oxygen. All right. So again, this is a prediction. It's just things that you think that might happen in there. So you can put whatever you want for the prediction, and I shall read on. Temperature and pressure increase with depth. Ooh, just learned something here, didn't we? It is hot in deep mines. Oh, it is hot in deep mines as well. This is a clue that it is hot inside Earth. It gets hotter as you go deeper. The temperature is about 50 to 53 degrees Celsius or 127 degrees Fahrenheit. That's right. Thank you, ladies in class, for looking up Celsius and Fahrenheit. I remember my science period, too. We had to look up the difference and which one was which. Near the bottom of the deepest mine and about 190 degrees Celsius, which is 374 degrees Fahrenheit, near the bottom of the deepest well. There is no way to measure the temperature of Earth's center. Scientists estimate that it is about 6,000 degrees Celsius, or 10,832 degrees Fahrenheit. That's pretty high. Pressure. Pressure is just as temperature increases, pressure increases towards the center of the Earth. Ooh, that's important. Now, if you haven't added this to your vocabulary book, I think you should. The weight of the rock on the surface pushes on the rocks below. This pressure makes the rocks below more dense than the rocks on the surface. Oh, look at this. Check mark. Going forward here. So let's answer. Read the check. Describe. How does pressure change toward the center of the Earth? Well, we just found out. Starting here. The weight of the rocks. E-I-G-H-T, W-E-I-G-H-T, the weight of the rocks on the surface. You okay? What was that? Pushes the rocks below, causing them to become more dense. What was that? She okay? What was she laughing about? Was it okay? I don't know what she was laughing about, but you guys heard it. I didn't do it. Whatever it is. Moving on. All right, so deep wells. The high temperatures and pressure inside Earth make it impossible to dig deep wells. Therefore, scientists have sampled only a small part of the geosphere. How can scientists learn about what is below the deepest wells? Here we go. Using earthquake waves. Scientists use indirect methods to learn about what is inside Earth. So how can scientists learn? Answer our own question. Most of their data comes from studying earthquake waves. How can scientists learn about what is inside Earth by using earthquakes? Earthquakes release energy in the form of 3 types of waves. The waves move through Earth. They move in different waves through the different materials. They speed up in more dense materials and slow down in less dense materials. Some waves change direction when they reach certain materials. Others cannot travel through some materials. By studying how the waves move, scientists can learn about the density and structure of materials on Earth. That's cool. That's important. Actually, I just learned that myself. I would circle that if I were you. That's a very important question. I'll probably bring it up again in class. All right. Earth's layers. As you learn, difference in density results in the materials within Earth forming layers. Each layer of Earth is made of different materials. The densest materials are at Earth's center. Okay. So here we're talking about the layers, and again, we did this in class, looking at the different layers using a cupcake. We know the layers are the crust, the mantles, and core, which we have the magma. All right, so, in our right, baby. Let's see if Katrina remembers. What are the layers of the Earth? And go. Testing, go. Wait, I didn't even get to there. Okay, look, okay, and go. Inner core, what now?
Inner core.
Oh, inner core, outer core. Mantle. And crust? Doesn't that make you want to make a pie or something? Okay, never mind. And maybe it's just because I keep hearing the word crust. Makes me want to make a, have some like pie. Anyway, so let's talk about the crust. And let's see if I can get the computer to read. I'm using the Kami app again. Like, this is perfect. I'm hoping more people will pick up on this app and use it to help you with the reading. Let's see how it does. There we go. That was riveting. Okay. So, and again, if you don't like the way that this particular style is, you can always go here and you can change the voice. You can even change the language and you can change the speed. Okay. So, that was so dry. I'm going to have to remember what it said. I do know the type of things we talked about, which are in this question right here. But since we have a check mark right here, I know it's going to ask me a question. So contrast. Compare the thickness and density of continental and oceanic crust. Well, let me tell you where we find that. We were talking about continental and continental and oceanic crust. Okay. So rocks. Okay. Here we go. The crust under oceans is called oceanic crust. It is formed from dense rocks that contain iron and magnesium. Okay. The crust on land is continental crust. Continental crust is about 4 times thicker than oceanic crust. And so that's how we're going to compare the difference. That sounds good to me. Oh, I know what I'm going to do. I'm going to use voice command. Continental crust is about 4 times thicker than oceanic crust. Period. Okay, you see how awesome that was? You can't beat that. I'm going to leave this video right here, and I'm going to start a second video. So this will be part 1, and I'll see you on the next one to help you with the rest of the homework.